I chose the Seasonic X750 power supply. The included accessories are very nice. The actual power supply comes wrapped in velvet in the packaging, which is a cool touch. There is a hybrid mode for the fan that's set via a switch on the back of the power supply. And in hybrid mode, I only saw the fan turn on once during firm arc testing and some pretty intense PlanetSide 2. And even then the fan was relatively silent. One thing to note is that the flat cabling with this power supply is relatively stiff, and it is kind of tough to manage and route through your case. So even though it is somewhat low key, you may want to go with extension cables that are braided because they will move a little bit better and be able to route more easily. The DRAM is Team Extreme 2133 Cas9 1.5 volt. I did not choose the RAM because of Team Extreme. I chose the memory because it is using Samsung HC9 ICs. I really like the Samsung memory, and Haswell seems to also like it, as my memory has no issue running at the stock settings, and I even have a bit of headroom for overclocking on that. So I'm very happy with that DRAM. Didn't mention much about the GTX 780. It is a Gigabyte card. I chose Gigabyte because it was the lowest cost for the best warranty, a full 3-year warranty. Some of the manufacturers in the same price range were only offering a 2-year warranty, which is not great. The video card performs very well. I'm incredibly impressed by it. Let's go ahead and open up GPU-Z here. Yes, it is the Republic of Gamers branded version. I figured why not. So I'll open FirmArc, and we can get, FirmArc has an update, as always. So I'll open FirmArc, and I'll run it, and we'll go ahead and get an idea of temperatures. So right now, we have a 99% GPU load, which is pretty demanding. It's about a similar load to if I was at 2560 by 1440. And you'll see the CPU temperatures are rising a little bit. They're jumping around. My ambient's a little high right now for Southern California on the coast. It's at about 28 Celsius. But if you look at the video card, the EK Supremacy block is holding its own. The card has not gone over 36 Celsius, and in general, even at full resolution, I did not see the video card get over 45 Celsius with an even higher ambient of 29 Celsius. So I'm really happy with the water cooling setup, and it's performing really well. So we'll go ahead and exit FirmArc and exit GPU-Z. I have a few notes about the motherboard. The motherboard has a fantastic color scheme, as you saw in my other videos. I really like the UEFI Republic of Gamers BIOS. Looks like all the other ones have, but there's a lot of new and cool features. There's a quick notes feature that will actually tell you what you've changed when you go to commit your save, which is useful because you'll have the previous settings for reference. It's clear, easy to use, very stable. Everything is well marked. It's simple. There's LN2 features. There's a CPU tweaker heaven section that has tons of different voltages you can mess with, so it's got a little bit of everything for everyone. Another thing I'd like to talk about is the sound quality. So I consider myself to be a little bit of an audiophile. I'm relatively picky when it comes to sound and sound quality, and I had an Asus Rampage Genie 4 before I got this, or I had a Rampage Genie 2 before I got this Rampage 6, so 4-year spread there. And that board had the Supreme FX. It was terrible, so I got a PCI HT Claro Omega Plus that I really enjoyed. The onboard on this motherboard is just about as good as that fantastic sound card was. Onboard is light years ahead of where it used to be. The Realtek ALC 1150 codec is fantastic. It actually performs better than the dedicated Core 3D Creative chips they're putting on some motherboards. In terms of signal to noise ratio and a few other specifications, you can actually pull up the data sheets and check that out for yourself. The one downside is that it does use a PCIe lane, or it does not use a PCIe lane, but the Realtek does use CPU cycles. So, you have that trade-off, but nowadays it's not really too important. It is a codec chip and not a dedicated processor. It sounds great. The EL&A capacitors are as good as they are on anything else I've seen them used on for audio equipment. I really like that particular section of the PCB where the audio components are has its own separate ground and is isolated from the main PCB. I've had no issues with noise on the Realtek chip. It is shielded with a cover, and I usually get interference with motherboard audio. That is not the case here. It is performing very well, and I'm incredibly impressed with what ASUS has done here with the Realtek codec. I do have to say, I do not like the software suite. FanExpert 2 is great. It's got some really cool features. It works relatively well, especially with PWM fans. Voltage control's a little iffy, but it's still a fun tool. The suite on the whole is very bulky, resource intensive, has a lot of services it runs at startup. I'm not a fan at all. And the only reason why I had it installed initially, besides for testing purposes, is because even manually, I could not get a particular MEI or ACPI driver to install, and only when I installed the entire suite did the unknown device finally disappear in the device manager. So my guess is that, you know, there's something strange with one of the software that they bundle in that includes a driver that they don't have separately on their website. So, you know. But if you're wondering to uninstall their software package, you actually have to go through quite a bit of work. It's not straightforward at all, and it's very cumbersome. When you uninstall the package through their uninstaller and restart your computer, it will not completely uninstall. You'll immediately have ASUS log error issues because the services will remain there. So you will actually need to go in, elevate a command prompt, and then so you'll need to go and elevate a command prompt, and then once you're in your command prompt, you'll need to do a we'll just go ahead and show that right now. You'll need to run an SC delete command, and then to get the services you need to do and delete, go ahead and go to services MSC. When you're in services MSC, you'll see 3 or 4 ASUS services that were not installed. One of them is ASUS fan control, for example. You need to right click on that service, stop it, copy the service name here, paste that into SC delete, so you know SC delete ASUS fan control, and do that for each of the 3 or 4 ASUS services. You're not done after you do that. You still need to go into the task scheduler, and there will actually be an ASUS option here under the general software. You delete all of the tasks, then you delete the folder. Once you remove that and the services, restart, run a registry clean, and you'll have no more issues, and the ASUS suite will be properly uninstalled. And I recommend not using the suite. It has a lot of really weird startup stuff. For example, aside from the CPU cycle intensive services, when you're running their startup, it'll have a dock that pops up here, and constantly annoying to try to manage your power and change your fan speeds and things like that. Each time you start up your computer, you have to manually go in and disable that dock from showing up. There's no setting to automatically have the dock not appear on startup. It's really bad. So that's disappointing. They need to work on an update to fix the uninstaller and that dock configuration. But other than that, I'm really happy with the motherboard. So I've spent a lot of time with Haswell, and I feel like I've learned a lot about the processor, and I figure I would share that here. Just to note, on stock cooling with stock clocks, my Haswell chip would immediately overheat in any stability testing software, and in most games and encoding suites, it would hit well over 70, upwards of 80, towards 90 Celsius, which is insane for stock safe voltages on a chip. So you really need to get some extreme cooling here if you're planning on pushing this chip, or even, you know, if you have a high ambient like I do, you know, summer, for regular application usage. There's a lot of hearsay about the chip lottery for Haswell, but there's nothing really outside of circumstantial evidence. Some people are saying Costa Rica batches are better than Malaysia. Some people saying OEM is better than retail. Some people say if your stock voltage is between 1 volt and 1.1 volt, your chip is good. And other people are saying there's a bell curve where you set your voltage to 1.2, set your multiplier to 45. If you can post then you have an above average chip. But honestly, it really is all hearsay. In my experience, the only guarantee that you have is if Intel purposely bend your chip for you, i.e. you are a professional reviewer or you work at a large corporation, because this is an absolute lottery. Anything I've seen, anything I've read is totally contrary to the speculation that's out there. Luckily though, V-Core is still king, and the multiplier is also still king for hitting those frequencies, even with the DC to DC VRM on board, where we have to worry about that, and all the new Uncore settings. You can still really focus on your V-Core and your clock via your multiplier, and benchmarks are showing that Uncore doesn't make a huge difference, so you don't really have to worry too much about that unless you're overclocking for the sake of overclocking, which I think a lot of people watching this are, and I don't blame you. It's quite fun, but for average enthusiasts, you can just stick with multiplier and V-Core and be happy. At a minimum, though, you might be interested in knowing something outside of V-Core, so I figured I would share a little bit of that information as well. And the V-ring cache voltage on an ASUS board is important for your Uncore changes and stability there. You want to look at about 1.15 to 1.3 for most cooling solutions. That's your voltage range. The VRIN, or initial input voltage on ASUS boards, is important for your boot stability and posting to get past that UEFI into Windows. And you want to look at about 1.8 to 2.0 for most lower end cooling solutions. In general, I've actually seen that most of the ASUS voltages are pretty on key. The V-Core, once you start overclocking, if you leave that on auto, ASUS will ramp that up to the extreme. Do not leave your V-Core on auto. You will fry your chip. So focus on manually fine-tuning that V-Core. It's really important because the new 22 nanometer process is incredibly sensitive to high voltage over time, and they can die quickly if you are not careful. I've read many reports of early death at the 1.4 volt plus range, so you really need to hone in on that voltage and be aware of your cooling solution and what you're really shooting for. 24/7 at 1.4 volt plus is a sure way for your chip to die very soon. Another thing that I like to say is I strongly recommend against AIDA64. Everybody is really pushing that right now, and I think it is terrible stability testing software. I can be stable in AIDA64 for 6 hours or more, and then immediately blue screen for V-Core in Prime 95, or even in a game or web browsing. I think that manufacturers and reviewers are recommending it to make Haswell chips look like they perform better than they actually do. So stay away from AIDA64. I'll talk about how I like to stability test this chip, and I think you'll find that it's a much better solution and makes a lot more sense given how this processor works. You also might have noticed, looking at my core speed here, they changed the idle core clock in the power saving adaptive voltage mode to an idle of 1.6 gigahertz to 0.8 gigahertz. So that's an interesting change. Not really sure about that. Might be because of the IPC of this particular chip and how well it performs, that 800 megahertz is an okay idle. And in my experience from casual usage, it seems like it has no issues with power-saving compute work. The AVX instructions that you have been hearing so much about are very demanding, and in fact, to keep up with them, Intel is cheating, and they assume that AVX will not be run for long periods of time. If you're using default, adaptive, or even the old school offset style voltage, AVX instructions will automatically override the voltage table and increase your voltage, regardless of what you set as your manual voltage for adaptive, or under an ASUS board, your maximum turbo adaptive voltage field. If you're overclocking and you run something with AVX, this could lead to dangerously high voltages. After testing various voltages, all the way from 1.2 to 1.4, I saw that AVX would increase the voltage over a maximum between 0.06 and 0.08 with adaptive or offset plus AVX. So, to set your maximum non-AVX voltage with an ASUS board, to recap, you want to go into the OC tweaker, change your manual voltage setting from disabled to enabled on manual, and then you want to enter the voltage into your ASUS adaptive turbo voltage field. If you really want the power savings from adaptive, and I think you do because they are very impressive, I have these recommendations. First, use hardware monitor for your voltage readings, not core temp or something else, and ignore VID. Only pay attention to vCore. VID is what the processor thinks that it's getting. vCore is what the table is actually supplying to the processor. So vCore is what's important. VID is often totally wrong. As you've probably seen here, some of the fluctuations have been off. Now, the other feature of this processor is that at 100 Celsius, it will not fail during stability testing. The CPU will automatically throttle down, and this is a little bit different from previous chips. So you need to constantly be logging and monitoring your core speed during stability testing as well as your temperatures, because you might have inadequate cooling and not even realize it. So this is another thing you need to be aware of. Now, in terms of stability testing, to get back to that and really hone that in, you need to get Prime 25.11, which is the last version of Prime that does not use AVX, and you need to get a newer version of Prime like 27.09 that does support AVX. What's the point of this? You first need to make sure your chip can run at a manual voltage for your specified multiplier settings and your desired vCore. And then you want to try about a minimum of an hour in 25.11 and a minimum of an hour in 27.09. Now you'll need to watch and see what your CPU vCore gets to make sure that your actual turbo or your maximum fake adaptive is okay when it's increased with AVX. So 25.11 will not do AVX, so you'll see your turbo be utilized, which is the voltage that you entered. And then once you hit AVX, you'll see it increase your voltage by 0.06 to 0.08. And you'll have to see if your processor won't throttle under that. And you'll also have to see if the boost that's automatically applied is enough to handle those new demanding AVX instructions. If not, you may have to go back and increase your maximum turbo, and you'll have to retest on 25.11 as well. So just to show you an example of that, we'll go ahead and run the older version with non-AVX. Here's the voltage with a little bit extreme LLC applied, so I'm at 1.28. It kicks it up to 1.296 with LLC. That's load line calibration. Then we can see our temps. I usually, once I get to the more intensive tests in this version of Prime, I'll get to about 75 Celsius. So we'll go ahead and stop all the workers there and exit that. Now, let's actually run with the AVX instructions so you can watch that voltage and temperature drop there, or increase there. So now, look, 1.376 with LLC and AVX. This is automatically overridden. I did not set this voltage anywhere. The Intel processor does this for you automatically, and most people are not aware of that. And you'll see what that'll do to the temperatures there. And we'll just run that for a little bit. So in my experience, if you get a blue screen within 5 minutes, your voltages are not even close to what they need to be. So you need to severely increase them and retest. After you get each test running for an hour stable, go back in, play with your settings some more. Then you need to get both versions of Prime running at 6 hours. And you need to watch your temperatures, log them, and make sure you're stable under both versions of Prime, AVX and non-AVX. If you can do Prime for 6 hours in both versions, I believe you're 99.9% of the way there to total stability. I've seen Prime fail after 2 hours, but after 6 hours is a very rare occurrence in my experience. 6 hours usually gets me where I want to be, and on other chips I've overclocked in the past, 6 hour stability has not netted blue screens in any usage. So, another guideline I like to provide, on summer ambient, 1.3 volts is uncomfortable on air and 1.4 is uncomfortable on most water setups, so stick to 1.25 volts on air and 1.35 on most water, not extreme water, and that's with the AVX voltage boost. So just to show you how much of a lottery this is, I have a Costa Rica, which is supposed to be the better chips, and it does 3.9 stock turbo at 1.12 volts, 3.5 stock at 1.04 volts, idle 0.8 at 0.704 volts. But to reach 4.6, I need a non-AVX voltage of 1.28 to 1.296 volt with LLC, and to get 4.6 AVX, I need 1.375 volt for stability. Now, after 6 hours of AVX testing on my water setup, when I get to test 18, which is a very intensive test, I see temperatures actually hitting 100 Celsius on water with a 29 Celsius ambient for a couple minutes. And that kicks me down to a throttle of 4.3. So even on my setup, there's issues with the heat transfer on these Haswell chips. Now, in Prime 95 with 29 Celsius ambient and no AVX, I never got past 81. So that's just how intensive AVX and the increased voltage can be here. If you're interested in real-world temperatures during gaming with that same 29 Celsius high ambient, CPU-intensive games like PlanetSide, and a little bit of encoding work, I never saw load temps get past 54 Celsius. So, really to recap, you really need to be careful when overclocking, especially with AVX and adaptive, even though I do recommend adaptive for the power savings. Overclocking can be tough on this chip if you really want to push it, or it can be easy if you're okay with about a 4.4, 4.5 overclock. The chip transfers heat poorly, and some people recommend delitting, and the reason why it transfers heat poorly is not because of the TIM that the thermal paste that they use on the die. Their thermal paste is actually very good. It's because there's a small gap between the die with the thermal paste and the top of the IHS, the heat spreader, due to the black silicone caulking on the side. And there's a lot of information to support that. So you can decide if you want to delid. I don't recommend it, and most overclockers don't, because then you lose Intel's replacement warranty. And it's only $25, and they'll replace your chip if you burn it out during overclocking. So I think the high temperatures are a relatively good trade-off for being able to really push your chip to the limit, even if you do have to put it under some more cooling. And in terms of an upgrade, I really felt that this processor was worth it over my i7-920D0 at 4.1 GHz. In all games and applications I use, it is doing much better. And once you factor in the AVX instructions, the G-flops on this chip go through the roof. Without AVX, Haswell at 4.5 to 4.6 GHz is a Sandy at 5 GHz. And there's a lot of future potential here with the multi-core, multi-threaded software that's around the corner, especially thanks to the new consoles we're seeing being released soon. And 1150 has one upgrade path left before a new socket is introduced, so it's good to buy in now. Take advantage of that tick, because 1150 will be around for that talk.